Welcome to part 3 of the RuneScape GUI automation botting tutorial. It's Ben again, and this is Learn Code by Gaming. Thanks for sticking with me. A quick reminder that you can find the source code for all of these videos in the description. Also, remember that this tutorial is for educational purposes only. If you run this bot somewhere where it's not allowed, it's going to get banned. Okay, so we've got a lot of things to cover in this video. We want to be able to move to different trees and chop them down, instead of just waiting for the same tree to respawn. We also want to automatically drop the logs out of our inventory, so that it doesn't fill up with useless logs. And once we've done these things the painful way, I'm going to show you how to do pixel color matching, so that our code can actually see what's going on inside the game, and it can try to find tree locations for us. So let's try to get it to click on two different trees. So I'll aim at this tree here on my left, and then the tree to my character's right, and we'll see how that goes. So I'll start by getting those tree pixel coordinates first, like we did before. Printing the screen. Then in Paint, this first tree location, 758 by 538. And I'm actually going to move these pixel coordinates to their own variables. So to do that, again, we use var. I'm going to call this first one first tree x. We'll set that to 758. And I'll create another variable for the y. Then I'll create another set of variables for the second tree. So now I'll go back to my screenshot and get those coordinates. It's like 1200 by 708. So now in our loop, let's click on the first tree location first. And then after we've chopped down that tree, let's just copy this bit of code, paste it, and this time we'll click on the second tree. All right, so now our code is going to click on this first pixel location. And then it's going to wait 8 seconds, and then it's going to click on this second pixel location, and then wait another 8 seconds. So let's run this and see how well it works. Okay, so you can see that it worked pretty well the first try, but once our character walks somewhere, that changed the pixel location of these trees, and so now it's no longer clicking on them correctly. So what we could do is we could try to micro adjust those pixel numbers until we get to a position where we are balanced and we are clicking on two different trees every time. All right, so I wasn't able to quite get it with that last location, so I'm just moving to a different location with two different trees. I think the best way to go about this is to just manually click on the trees a couple times, back and forth, until you end up in sort of a consistent pattern. Okay, so what I've figured out is, after you've chopped down the second tree, you can use that image to grab the pixels of the first tree you want to cut down. And then you'll want to go ahead and chop down that second tree manually. And then you can use this screenshot to find the coordinates for the second tree you want to cut down. And then, of course, before you run your program, you're going to want to go back and manually cut down that second tree first. Now let's run it and see if we've got it working this time. All right, so I've finally got a loop here, two pixel locations that if we click them back and forth, it will continuously cut down trees forever. And of course, once you get to this stage, be careful not to move your character manually at all or move the camera. And of course, as we've been developing this, our inventory has been filling up with logs, and you've been having to manually drop all these logs. So now let's write some code to manually do that log dropping for us. And this is going to be easier than clicking on the trees because the inventory is always at the same pixel locations on our screen. And I'm going to have us just drop the item that is in this inventory slot right here. So in our code, let's create new variables for the x and y of that inventory location. I'll use paint again to find that location. 1882 by 830. And so in our main loop here, we'll first chop down first tree. And this code chops down the second tree. And in between each of those steps is where we want to drop our logs. And to do that inside the game, we would of course go over to our inventory, right click on it, and move our mouse to dropLogs, and click on that. So let's just simulate that behavior with our code. So we first need to move our mouse to that location. So robot.mouseMove, go to the inventory X and the inventory Y. And then once we get there, we want to do a right click. To do that, we call mouse click again, but we want to give it an argument, which is just a string that says right in it. And this indicates that we want to do a right click instead of a left mouse click. And then once we've done that, we want to move our mouse down a few pixels. Let's figure out exactly how many. So I'm going to take a screen capture with this menu open. And you can see we right-clicked about at the top of this menu, and then we now want to click the drop logs. The top here is about 830 pixels, and we want to go down to about 900 pixels. So that's a difference of 70 pixels. So in our code, let's move the mouse again. And we want to move down 70 pixels from where we were before. So I'm going to give it the same x argument, but then for our y argument, I'm going to add 70 pixels. So by adding 70 pixels, that's going to be 70 pixels lower on the screen. And so this is what we call relative motion, because this mouse movement is relative to the previous mouse position. And then once our mouse gets there, we just want to do a normal left click. And then it takes a second to actually drop those logs after you click that menu item. So let's pause our script for a second while it does that before we click on the next tree. And then after we chop down our second tree, we want to do the same exact thing. We want to drop the logs that we collect from our inventory. So I'm just going to copy and paste the code to do that. So let's try this one out. All right, so it looks like it successfully dropped the logs out of the inventory. Now, whenever you start copying and pasting segments of your code, like we did for the drop logs, that's usually a good indication that maybe you should think about creating a function. By moving this code to a function, it'll help you get more organized and it'll simplify this part of our code. So let's go ahead and do that. Down here, I'll write function, call it drop logs. We don't need to pass in any arguments. And then the content of our function, I want to be just this code here. And then whenever I need to use this code, I can instead just call drop logs. And you can see by using a descriptive name for a function like drop logs, we don't even really need this comment anymore because we know what the drop logs function does. I missed one part here, our inventory x and y coordinates. Those will also need to be moved to our function. That's because any variables defined here in our main function won't exist inside the scope of the dropLogs function. But robot, which is defined outside of any of our functions, this is a global variable, so it is available inside any of our functions. All right, so let's turn our attention back to the chop tree part of our code. If you followed along at all, you know that finding these coordinates such that it would actually successfully go back between one tree and another was really difficult and really tedious. So let's talk about a better way to do this. So looking back at the robot.js documentation, let's go down to the screen section and specifically the screen.capture. So what this method will do is it will take a screenshot for us, just like we've been doing with our print screen button. And then from that screenshot, we can call these bitmap functions, like color at, that will give us the color at a given pixel position. So the concept's going to be is we're going to take a screenshot with our code, and then with that screenshot, we're going to search around for one of these brown tree trunk colors. And once we find a pixel with one of those colors, we're going to say that's a tree, and we're going to go chop it down. So the first thing I want to do is write a test function that will allow us to test these screenshot capabilities and make sure it's working how we expect. Let's go down here below dropLogs. I'm going to call this function test screen capture. And the best way to figure out how to use this is actually to look at the documentation, and they've got an example. So in this example code down here, you can see they're calling robot.screen.capture along with these arguments. The first two are the x and y coordinates of the upper left-hand corner of your screen. Well, it's the upper left-hand corner of the area you want to capture. And then the width and the height coordinates allow you to set the size of the image that you're capturing. So I'm going to go ahead and copy this code, paste it in. So here 0, 0 is going to be the way upper left-hand corner of our screen. For the size, we could put the monitor resolution that we have to get the entire screen. So I'll go ahead and do that. For me, that's 1920 by 1080. So I'll make a note that we're taking a screenshot. And then if I just screenshot my IDE here, I know that I'm going to have this unique blue color in the upper left-hand corner. So why don't we go ahead and test that, see if that's what we actually get. So I'll create a new variable, var pixel color. And we're going to use the image, the screenshot that we just took. I'm going to call color at on that screenshot. And then the pixel I want to check out is one of these bright blue colors. And so you can determine this again using paint. I already looked it up and it's at 3018. And then we want to see what color it finds. So to do that, I'm going to just print it out to the console. Console.log, pixel color. So now let's run this test function. I can do that easy enough by just going down to the bottom of the file, calling that first. I can comment out main, so none of our main code is going to run. If I run this, you can see the output I get for the color there is this 23A9F2, and this is a hex color value. So if we want to see what this color looks like, we can just go to Google. All right, so in Google I typed in hex color, then you can replace the hex color here, and then it is showing that that is this bright blue color that I was expecting. So it's always good to do this when you're working with a library. Write a quick test function, make sure that the methods that you're calling in that library are working as you expect, and that'll make it easier when you go to actually develop the code that you want. All right, so I'll put our code back how it was. I can leave this test screen capture function here. It won't get called, it won't get run, but it's still around just in case we want to use it still. So now I want to write a function that finds the tree for us using the screen capture technology. So when I'm writing a new function that I know is going to contain a good bit of logic inside of it, I usually like to start with writing the code where I call the function first, and then that will inform what the actual function I write should look like. So I know in our main function, we won't need to have any predefined x and y coordinates anymore. I also know we won't need to select the second tree manually. So this code is really just going to chop down the tree we found. Now we don't have these first tree x, first tree y variables anymore, so we'll need something different in there. So maybe this is tree.x, and we'll call this one tree.y. And by using this dot notation, it means I expect my function to return an object, and the way you access properties on an object is through this dot notation. So now let's define that tree variable, which will be populated by calling the findTree function. And then we got to think about the scenario, what if it can't find a tree? What should we do? So if it can't find a tree, I'm going to have my function just return false. That way I can say if tree is equal to false, we'll write to the console, we'll say could not find a tree. And then when we don't find a tree, let's go ahead and break out of this infinite while loop, because the code beyond here won't work if we don't have an x and y coordinate. So to exit a loop, you can always just call break. Break is another JavaScript keyword. And I'll put a comment here. If we can't find a tree, write an error message and exit the loop. All right, so the logic inside of our main function looks good. Looks like it makes sense and it's nice and concise. Now all we need to do is write this findTree function. So again, we define a function with the function keyword. Got the function name. We don't need any parameters for this function. Use the curly brackets. Now we can start writing the body of our function. So the first thing we need to do is we know we need to get a screen capture. So I'll copy that code from our test function. Now we need to think about, do we really want a screen capture of the entire screen? Looking at the game, I think it'd be better just to have a screen capture of maybe sort of this area here, the places where trees are likely to be. That way we don't accidentally find any brown colors, say over here on the map, or maybe down here in the user interface. And I could write those pixel and size values right here, like we did before, but I could also create some variables. And the nice thing about creating variables for this is we can use descriptive variable names that helps remind us in the future what these parameters actually are. So we know that's x and y. This is the width. This is the height. And you can actually define multiple variables on one line in JavaScript. And the way you do that is x equals, I'm going to start this at the 300 pixel. You then use a comma and you can declare your next variable. Y equals 300 also. And for the width, have this be 1300 pixels wide. And the height, I'm just going to do 400 for the height. So now that we have a screen capture, the next thing we need to do is we need to figure out what color we're going to look for. So inside the game, we know we want to click on one of these tree trunks. And you can see they're all brown, but there's a few different shades of brown in there. So there's actually more than one color that we want to search for. And instead of saving each one of those colors we're searching for to its own variable, this is a perfect use case for a data structure called an array. So to create an array in JavaScript, I'm first going to declare a variable just like we did before, tree colors. And then to create an array, you use square brackets. And each element inside the array is going to be separated by commas. And we want to store strings in here, and those strings will represent the colors that we're looking for. So to find those colors, I'm again going to go back to Paint. And Paint has this color dropper tool. Use this color dropper to click on the brown color we're looking for. And when you do that, the color selected up here where it says color 1 will change. And with that highlighted, you can click Edit Colors. And it'll show that brown color right here. And unfortunately, it doesn't give us the hex value right here, but it does give us the red, green, blue value. And so what we can do is we can go back to Google over here. We can take that red, green, blue value, which is also known as RGB. We can type those in and it'll give us the hex. So here we have 91, 70, 42. So now you can see we have this brown color showing up in Google, and it gives us the hex for that. It's 5B462A. So I can copy that and put it as the first item in our array. Okay, so I went and sampled several more of those brown colors on the tree trunks, and I put all of those into our array. And I basically just kept finding new colors until I started seeing a lot of repeats. But this should give us enough brown options for our code to find a matching pixel. Okay, so the next thing we need to do is we need to start searching our screen capture for these colors. And we know we can find the, let's call this sample color, by calling image.color@, and then we give it x and y coordinates in here for the pixel we want to check. And so the 0, 0 coordinate in our screen capture will be the top left pixel in the screen capture, which corresponds to the 300, 300 pixel on our screen. So if we did just check 0, 0, that's of course unlikely to contain the brown color. What we really need to do is we need to loop again. We need to loop through all the pixels inside the screenshot we captured. And to do that, we could use a while loop again, but I'm going to show you a different type of loop. I'm going to show you a classic for loop. So a for loop begins with the keyword for, and then parentheses. And the first thing we do is we create a variable here that is our iterator. And convention is to use I for this iterator. And then we use a semicolon. And then we need to say how long we want our for loop to run for. For now, I'll just put in while I is less than 100, another semicolon, and then we need to say how quickly do we want to step up our iterator. And usually I++ is the answer here. That'll increase I by 1 every time through the loop. And then we use curly brackets to define the body of our loop, just like with a while loop. I'm going to move this sample code into there. And then we can use I in our loop. So if I were to put I as the first parameter in the color we're looking at, first time through this loop I would be 0, so we look at the color at 0, 0. Next time I would be 1, so we'd look at the pixel at 1, 0. And so on until we looked at the first 100 pixels in the top row of our screen capture. And so one thing you could do is you could set this while I is less than the width of your image. So that'll allow you to look at the entire top row of the screen capture you have. And then you could make another for loop nested inside of this one. And I'll change this I to a j for the inner for loop. And you could do this while j is less than the height. Make sure to close that second curly bracket. And then we could set j to be our y coordinate. And so this code would sample every pixel inside of our screen capture. The first time through, I would be 0, and then j would go from 0 up to the height of 400. So it would look at the entire first column of pixels, and then it would move to the second column of pixels, and so on until we looked at the entire screen capture. So this is one way you could do it. One problem with this approach is that it's going to preferentially find brown pixels on the left-hand side of your image. And I think we could probably get some more natural behavior if instead we just sampled random pixels inside of our screen capture. So I'm going to get rid of this inner for loop. I'm also going to change this while I is less than 100 again. So I want to sample 100 random pixels inside of our screen capture. And to do that, I'll need a random x and a random y. So let's create some variables for that. Random x will equal something, and then random y. And then to figure out how to get a random number inside of JavaScript, all I would do is search how to get a random integer inside of JavaScript. I'm going to usually look for the Stack Overflow link. Then inside here, you'll find all kinds of solutions. And I'm just going to grab this first solution here, the get random int, because this allows us to provide a min and a max, which is perfect because we want to constrain it to be an integer that is a pixel inside of our screen capture. So back inside our code, I'm going to go below the sleep function here. We have another kind of third-party function. Now that we have a function for getting a random integer, we can go ahead and use that to find our random x and our random y. Get random int. 0 will be our minimum. And for the maximum of our x coordinate, we want to use the width. And if you were to read the details of that Stack Overflow post I found, this get random int min and max is actually inclusive of both the min and the max. So if we say that the first one is 0, 0 is a possibility to be returned from this function. And the max as well, so 1300 is also a possibility to be returned. But pixel column 1300 doesn't actually exist in our screen capture. That's because it starts counting the pixels at 0, not at 1. So to correct for that, we just need to subtract 1 off of the width. So this will give us a random integer between 0 and 1299. And to get our random y, it'll be similar, except instead of using the width, we'll use the height to get a random integer between 0 and 399. So we have our random x and y inside of the screen capture. We've sampled the color at that position. And now we want to check to see if that sampled color is one of the brown colors that we're searching for. So in JavaScript, arrays have a method called includes. And if you give it a value, it will return true if that value exists inside of your array, or it'll return false if that value doesn't exist inside the array. So to use that, we'd write if treeColors.includes, parentheses, and then here we want to give it the sample color, and then the curly brackets for what we want to do if this if statement evaluates to true. And so if this sampled color exists anywhere inside this array, this list of colors that we're searching for, it's going to enter this if block. So once we found that color, we know the x and y positions inside of the screen capture where that color exists. But we got to remember we didn't take the entire screen in our screen capture. We started at the 300 pixel for the upper left-hand corner. And so we need to account for that when we're converting this XY coordinate system from our screen capture to the screen itself. So the screen x is going to be the random x plus the x position where we started our screen capture. And screen y is going to be just about the same. We'll take the random y value that we checked and add in the y position from the screen capture. So now that we found the pixel on the screen where that color exists, let's first print that out to the console. And doing this isn't necessary, but it'll help us debug our program. And you'll notice I have some strings here, like found tree at, and then to include the variable values to that string, you just use the plus sign between them, and this does string concatenation. And so when this prints to the console, we should expect something like found tree at 400, 600, and then color, and then the hex code for the color that it found. And so now we want to get the screen x and y out of our find tree function and pass it back to our main function, where we can then use it to do our mouse movement. So to do that, we use a return statement. And then we want to return an object here because that's what we are expecting inside of our main function. And so to define an object, you use curly brackets. And then you define the properties inside of the object. So we want to return x, and then that's just a colon after that. And then you set the value for that property. So here that would be screen x. And then a comma to create the next property, which is y. And that'll be equal to screen y. So this find tree function will now return an object, contains an x and a y property, and those values will be the x and y positions on the screen where the pixel we're looking for is at. And then we can access that in the main function. We're saving that object to this tree variable, and then we're using the x and the y properties on it. But if our find tree function doesn't find a tree, we want it to return false. So let's go ahead and do that down here. If it goes through this loop 100 times, it never finds these colors anywhere. We want it to return false. I'll even put a note here, did not find the color in our screenshot. And just as another example of how these return statements work inside of functions, we can just look at that getRandomInt function that we copied in, and you can see that it's also returning this value here. And then we're using that up here where we call it this getRandomInt is going to return one of those random values, and we're going to save it to one of our variables. And then these if statements, that's a new concept for this video. The way if statements work is it's going to run the code inside of the curly brackets if the condition inside of these parentheses evaluates to true. So in this case, we're checking to see if this trees array includes the color that we sampled. And then we have another example in our main function in the primary while loop. If this find tree function returned false, then it's going to execute this code. But if it doesn't return false, if it returns an object, it's going to skip over this code and it's not going to run it. Also take note that when we're checking for equivalence in JavaScript, we use the double equal signs versus the single equal sign is used for assignment. So this equal sign here takes whatever is returned by find tree, it assigns it to this tree variable. Versus down here, we're looking at what value is inside that tree variable, and we're saying, does it equal to false? All right, so that's quite a bit of code we've written without testing anything. So let's go ahead and give it a test. The two things we're looking for is these log statements. Is it actually finding any trees? And then inside the game, is it actually clicking on those tree trunks? Okay, so when I ran my code, I got an error message. So this is good to review. So when you get an error message like this, you want to look at two things. First, you want to look at the message itself. This is saying referenced error, sampled color is not defined. So that's saying that we are referencing a variable here that doesn't exist anywhere. And then right below that, it actually tells you exactly what file that error occurred in, then also what line, so line number 60, and then even what position inside of that line. It'll be the 88th character over. So if I go to line 60, I see sampled colored here. And sample color doesn't exist anywhere. I actually called this sample color, not sampled. So I'll go ahead and fix that. And then we'll run it again. Right there, we had a successful click on one of our trees. And then we're still dropping the log successfully too, and it found another tree. And of course, sometimes when we run our code, it's not going to find a tree, so we get this could not find a tree message, and our code stops. So one thing we could do to address that is we could increase the number of times we're searching for random pixels. You could even increase this up to 1,000 if you like, it would be fine. And then a couple other issues we're seeing. If you let this run for long enough, you'll see you eventually click on somewhere that does look like a trunk, but it actually results in not a tree being chopped down, but your character just walks over there instead. And we'll fix that in the next video. Another issue you might find is you could find your character in a situation like this where there are no more trees on the screen. So let's address that issue right now. If we ever get this can't find a tree situation, instead of just exiting our code, why don't we try rotating the camera instead? So that'll take us from a situation like this. If we rotate the camera, hopefully we'll get some more trees in view. All right, so to add this feature, remember when I'm creating a new function, I like to start by calling the function. So in our main function, in our main while loop, if findTree returns false, instead of printing out this error message, I instead want to rotate the camera. So this function doesn't exist yet, but I'm going to create it. And then once we successfully rotate the camera, instead of breaking out of this loop, what I instead want to happen is I want to go back to the beginning of the loop and go and call findTree again. So in addition to break, there's another keyword you can call inside of loops called continue. So when you call continue, it's going to skip over the rest of the code inside of your loop, and it's going to go back to the beginning. So now we just need to write our rotate camera function. I'll put this below findTree. And I think I'll start with a log statement. I'll just say rotating camera. And then inside the game, to rotate the camera, we just press down on the left or the right arrows. So let's look at the robot.js documentation again to figure out how we press keyboard keys. So I'm looking at these keyboard methods. Let's look at keyboard tap. Keyboard tap presses a single key, but key tap is going to press down on a key and then lift it up again immediately. What we want to do is we want to hold down a key for a little bit. So to do that, we can use key toggle. We can initially say that the key is down, and then after waiting some period of time, we can call it again and say that the key is up. So inside our code, we're going to call robot.key toggle. First, it wants the key that we're going to press. Let's press the right arrow key. And then to start with, we want to press it down. Then let's wait. We'll just wait 1 second. Then after 1 second, let's toggle the key again to lift up on the right arrow key. And the way that I know that the right string means the right arrow key is back in the documentation. It has a list of all the different keys, including right for the right arrow key. And then the documentation also mentions you use the down or the up string to indicate the key toggle. Alright, so to test this out, remember that rotate camera is only going to be called when we can't find a tree. So to increase our chances of not finding a tree, I'm going to go down to the find tree function and change this random sampling from 1,000 to just 10, and that'll increase the chances that we can't find a tree pixel. So now I'll run this. And there you can see that we are rotating the camera in almost every cycle through our loop. So if I increase this back to 100 random samples. I'm also going to move my character so that there's some trees in his view again. Give that a run. And then if you run this long enough, you'll eventually see some screen rotation happening along with chopping down trees. And then it's always good to look back at your log to see what trees you found, what color you found, and then also your rotating camera messages. So that's where we're going to end part 3. Right now, our bot has made a lot of progress, but it's still very fragile and prone to errors. In the final video, part 4, we're going to address all the defects and really polish this into a strong automation. The key programming concepts we discussed in this video are arrays, traditional for loops, function return statements, if statements, and loop break and continue statements. Again, I encourage you to read more on these topics to solidify your understanding, and I'll have links for that in the description. So like I said, we're going to take this brittle bot and really take it to the next level in part 4 of this tutorial series. You definitely won't want to miss it if you've made it this far, so remember to click the like button, and I'll see you over there.